Army, Navy, Smithsonian, Weather Bureau, across the nation. Everybody who had some expertise in the nation was brought to the same table, in the same committee, okay, to develop a consensus on practical problems for solving this national challenge. Okay, what most people don't understand, everybody remembers they did great work on airfoils and propellers and low drag reduction and cowlings, and they did the work on X1 and X15. Most people forget the history of the first 5 years. It took till 1920 for them to actually start operating the first Langley wind tunnel. So they had some things to do there. And what they did is within the stimulate the industry, there was a lot of things you could do at very low cost. So what were some of these successes? Okay, and I'm saying this because we don't have the equivalent today that brings together the entire nation of Air Force, NASA, DOT, commerce, and industry in one big way. We have some equivalent bodies. So they took a holistic systems view of the entire industry, okay, of national priorities. If industry said investment was a priority or market's a priority, whose job is it to help them with investment? It's not my job at NASA. It's not the job at anybody else. So there are gaps. I'm talking about gaps there. There's other gaps here in what we're doing and how we're thinking about this. So they solve practical problems in partnership with industry. So first of all, one of the first most important things they did is they eliminated the fight between Glenn Curtis and the Wright brothers. They basically gave them a deal they couldn't turn down, which is you're going to get $1 million for licensing your patents, or we're going to break it. Which one do you want? We have the right to do so. And the Wright brothers and Glenn Curtis took the deal. Created the the Aircraft Manufacturers Association, which much later became AIAA, and eliminated that fight. So they created cooperative partnerships between government and industry. One of the most valuable ones they did started in 1916. We had some of the most advanced engine technology in America, but we had really poor aircraft engines. And the engine technology was in the automotive industry. And what we had was a situation where the leading automotive engine manufacturers would say, we'll build you this great engine, Department of War, okay, but they all had a different way they were going to do it. And the Department of War would say, we want a great engine, but we can't figure out what industry, what to do, because they keep on saying different things. So they actually started getting in a tit for tat and getting a little upset at each other. And the NACA called a national public meeting, a meeting of the executive committee of the NACA in 1916, and invited the Department of War and the leaders of industry and basically locked the doors. And for the first part of the meeting, everybody got into pointing fingers and blaming the other guy, why we weren't doing anything about engines. And by the end of the meeting, they had broken through it and basically came up with the top level requirements of what then became the Liberty engine, which became instantly the best engine in the world. And so in those planes, Europe and France had better airplanes. Britain started buying our engines. We were exporting them overseas to put them in their planes. In 1916, imagine this, a government agency advocates another government agency start buying commercial services within its first year of existence because they know the industry needed a market. 9 years before the Kelly Airmail Act was created in law, the NACA was urging the U.S. Post Office to buy airmail services. So they persuaded commercial insurers to buy insurance. There was a healthy insurance industry, but nobody was insuring this. This was a practical problem of the industry. So they recommended budget increase for Weather Bureau, and interesting, they recommended a year before it was created in law, what became the Bureau of Aeronautics to regulate the industry, the predecessor to the FAA. So these were extremely valuable, and I would argue just as valuable, if not more, because of their timeliness, as the technology developments that NACA helped later. So we all know about some of these, drag reduction across all vehicles. They are very open, published test data and shared with industry. You know, the low drag cowling engine, a whole bunch of other technologies. A key point I want you to notice, though, in every case, they were externally focused. They were developing technologies for a customer, either DoD or commercial customers that go into their systems, and it was broad and stimulative. So an outcome of thinking about an NACA approach. It develops really a national consensus on priorities. Now, we do some of this today. We do it in earth science. We do it in the Aeronautics Research Mission Directorate gets a consensus of priorities on aeronautic challenges. We do it on space science. But we do not have a national consensus of this room. If I asked every one of you, you know, you would come up with what you thought were the priorities. But as a room, we could not show what our priorities were for this industry. Or an agency can show what their priorities are, what the people they serve are, but from a national perspective, we do not have that. So what does it do? It broke through the background noise of competing voices. We just heard it talking about communications problem. Well, there's a lot of noise and a lot of voices. So if you had a national consensus, Congress actually likes very valuable the earth science prioritization, aeronautics prioritization, and the space science prioritization that's done as a national consensus of priorities on that. It enabled each of these agencies to coordinate their activities and be more effective. Those agencies sit at the table at the advisory council for the NACA were actually coordinating who was going to take on which problem. Once you had a set of problems, you know, the Air Force or the Department of War said, we'll go do that. Okay, that was a very effective, it emerged out of the process. Okay, so everybody gets to retain their own focus, but it still, as a committee as a whole, you have a broad systems view. If there's a gap, if there's something that somebody's missing, you notice it. Now that's where the NACA made recommendations to the President. As a group of the whole, they were listened to very powerfully. So defining the problems was half the battle, because once you define the problem, prioritize it, you could be effective about going out and doing it. Right now, we have no consensus what our human spaceflight program would be. So, just some thoughts about the NACA approach. Other characteristics relevant to stimulating the industry. So it's naturally focused on broad utility, broad and open publication results. We're not going to pick, you know, an NACA entity is not going to pick winners. It's trying to be as broad as possible, not tilt the playing field. And it had significant economic leverage across agencies and companies. So a couple other areas where it was used of appropriateness, both quite successfully. In World War II, the chairman of the NACA, Vannevar Bush, who we all know, got the president to create the National Defense Research Committee. Now, not much history is written about this these days and well known, but some of the things they produced, radar, sonar, bomb sights, and they set up the Manhattan Project. So they, in a very short period of time, a huge number of breakthroughs. Some people actually stated that Vannevar Bush, other than the President of the United States, was the most important person to winning World War II. This same issue, the same approach, version of it was used recently for the small aircraft industry, which was in serious decline, and setting up what was called AIAA to bring together companies and industry to advance technology and reduce risks in new systems for the small aircraft industry. And there has been a flourishing of innovation in that industry in the last 10 years since that AIAA did its work. So that's the conclusion of sharing some history, some thoughts. I'd like to open it up to any questions you may have, and please, my email's up here. It's hard to forget, charles.miller@nasa.gov. I'd welcome you getting in touch with me. Thank you.